You're just gonna let me walk by this universal
I was gonna
robot
just let you walk by this universal
and not talk
robot.
about it?
Yeah.
Treadmills. I'm trying to find flaws in the metric system. Second shop tour where I've said, I like your rack. Really? Oh my God. I'm distracted.
What could you be distracted with?
Hi folks, I am here outside of Amsterdam in the Netherlands with
Lawrence, Wijnschenk.
Of 3DTechDraw.
Yep.
Want to show us around?
Let's do it.
Cool.
Sounds like a plan.
So you were telling me in the car right here, your name comes from the fact that you started more on just the CAD side, software side?
Yeah, so what actually happened is my brother founded the company, and he started as a 3D design modeling guy, just that anyone could hire to do some of that modeling stuff. And he got into machining when one of his former employers was selling his milling and turning equipment. So he bought that, and from then on we were actually a machine shop instead of just a modeling business. So name is still the same.
Yes.
Everyone kind of knows us as 3D Tech.
Right.
Without the draw, like we use
that's
it,
funny.
but we're known as 3D Tech.
Got it.
By customers and suppliers usually.
Cool. And you guys are self-taught machinists in that sense then?
We're self-taught machinists. Like my brother did some kind of mechanical engineering education, and I didn't. I actually came from middle school, was looking around at what other studies I was going to do. Didn't really work out for me, so I came into the shop as I was already doing the website and other computer-related stuff, and got hooked on the machining. And essentially, anyone in the shop is self-taught, or at least taught by us. Together, we built what we know now with a whole lot of trial and error, as usually for the most. So there was no prior actual machining knowledge.
Yeah, right.
Which is cool because we figured it all out.
Well, and I think it's really cool is if some of you recognize Lauren's name from the Autodesk forums, yes, that is him. But like you bring in this like level of technology, like the way you modify posts, the way you handle some of the aspect of that element on the software side is really cool.
Yeah. The software side has become like my thing within the company. It's grown into a passion to get it to work properly. Take the software beyond its limits, make it work. Right. Use machines that aren't suited for this software, but make it work. Make it work and actually make money with it. And the software was the same. Like we learned with trial and error. Didn't have any proper training, but it felt simple. Start with it, start making parts, do it wrong, and then figure out there's more and more options. And then people like Rob Lockwood, who I found on the forums like years and years ago already. And those guys share knowledge, so I did too, and we all grew together with the software. And
it's cool.
That was cool. So
let's go look. Let's go look what that is.
Let's see what happens here. So this is our shop. We tend to jokingly say it's our hobby shed, like people work in their shed on their hobbies, and we still call it that way. Because it kind of feels like that, to be honest. Yeah. We're still doing what we love, what we like, together with everyone. Like, it's not just me or my brother or anyone. We're doing it as a team. Essentially, what you see here in the middle is someone programming. Everyone's got their own programming station. They run their own machine, program their own machine, and so everyone owns what they do because you've got your own machine. It's not that there's one guy programming and the rest just operators. Everyone makes their parts, especially since it's usually one-offs or 5, maybe 10. Doing more and more series right now as we're getting more machines, more hours in, but we used to do 1, 2, 5, something like that. Yeah. So it's cool that everyone knows their own machine.
But it's really an extension, I think, of certainly like my story and a lot of others, which is you grow from a one-man shop or a two-man shop, so everyone has full responsibility. You saw cut the material, you program the part, you set up the tools, you set up the machine.
Yeah, you do the whole journey, right?
Yeah.
And the cool thing is that if you have this kind of feel with everyone that works that way, like no one is excited to cut a piece of material on the bandsaw. Like you're excited to machine the part, but not do the bandsaw part. So when you've got spare time, you do it for someone else because we're doing it as a team, and any part that comes out there is as much my responsibility as the guy running the other machine. So we try and do it together.
But it's interesting. You say that, but I would say there's a distinct cultural difference between shops or companies that are very much like each man for themselves versus we fail and we succeed as a whole.
Oh, we succeed as a whole. Like,
it's got to be that way.
And of course we fail as a whole. As a part goes out the door wrong, it's like
everyone's fault.
Everyone's fault. Because there's so many steps that we should have all taken to do it. So it doesn't mean you gotta blame someone. We should have done better, and so we don't want to say you did this wrong because someone else will do something wrong the next time.
Right.
So we're doing it together, try and help each other out in any way possible. So we've got the height gauge right around here just to do some quick measurements in the shop. So this is just on the shop floor. So this was our main.
Very familiar.
Very familiar for you.
Same
was
one.
our main measurement device before we had the CMM, which we'll walk into later. I just used Lang vices everywhere, so just for holding the parts during measurement too. And no, these marks are just because of the
chips. That's
the
funny.
chips.
Interesting.
So and of course a whole lot of different measurement.
Cool! I didn't. Awesome.
Systems. So,
ID bore gauges.
And then you've got like. It depends on what we need, but like TISA depth gauge, 300 millimeters. So we want specifically this one, so you could have.
You just come back up into it
both ways. Yeah.
That's really cool.
So that's
Look at that.
Really
That's
cool.
awesome. Do that again.
So now it's just like a normal depth gauge, and then you just flip this around.
Yeah.
So you can just actually
come
measure grooves, stuff like that. So it says 2, but you can actually like set it to 0 now too.
Sure.
Yeah.
I like that.
Really want that one. And of course, like with many shops, this grew from mainly analog measuring devices. Like just these were our probably main gauge for a long time. But in the end, you need more because you get more people, need more measurements on a daily basis. So then we moved to the digital ones.
Yeah.
But it's always good to have backup, just especially for a lot of tools that are, or a lot of parts that aren't as accurate, like thread, no-go.
No-nos, yeah.
And we even got like big ones.
Oh wow, look at that.
In stock that we...
that's crazy.
So that's the kind of cool.
Yeah, that's awesome. So that's only a no-go. So the idea there is if that goes, you made it too loose.
Well, the thing is, this size, they don't make a two-sided one anymore.
Okay.
So I've got the go one here too.
Okay.
But
so a go should go and a no. Well, how does that work actually on a thread gauge?
On a thread gauge, like the go version, the green one should go in.
Yes.
And easily. I would say like you shouldn't force it.
Yeah.
And then the no-go, and once the no-go goes in, you know you've gone too far and it's too big.
If it goes there.
Depends. Right. Like if it's a threaded hole and the no-go goes in, it's
too big. Yeah, right.
Yeah.
Okay.
But it's pretty tricky because you use that, but there's other parts of the thread that you still need to check for. The bore diameter before you make the thread is still important because that could be wrong and the no-go would still not go in.
Yeah,
sure. So it's one of the measurement tools for your thread and not the only one, of course.
Oh, so is that on your Lang? Because we just got some stuff in as well. This is what you use to set your coordinate system off of a Lang system? Okay, awesome.
So this is that center of the plate.
Right.
We also use this as they have special systems for that as well. But if you have multiple plates that you want to connect. Like on the 3-axis, we've got multiple plates that you could put your vise in between 2 plates.
Yeah. Oh.
We use this one to
set
them and then lock the plates down.
So you can have something spanning 2 of them.
Even 2 seconden. So
I actually like that. You don't see metal switches as much anymore these days.
Those are great because you can just look into the machine and feel if the one's on or not.
Yeah.
I love that, especially for the cooler one. But especially like if you've got multiple plates like this, you use that one as well. Set it in between, lock both, and then you know they're all in a straight line.
Right. You guys are big fans of the Lang system, huh?
Yeah. We just moved these around so the plugs aren't in there. But we put the Lang on anything.
Yeah.
Make special fixtures, use all...
Right. So these are just giant soft jaws for op 2 on this part?
Yeah, these soft jaws you can actually buy from Lang.
Okay.
But we machine them ourselves because it's not that hard.
Yeah.
So we stock like a whole cabinet full of ones we've used. We just run out, so I've put in the planning that we need to make new ones.
Yeah.
But it's a lot cheaper and we've got the material, the machine, so why wouldn't you?
Yeah.
So
look at this.
Yeah,
look at this. It's a really big machine.
This is the machine of the shop. I can honestly say that we're real proud of this. It's amazing the stuff you can do with it. Essentially, this was originally designed as a machine that came from a lathe with live tooling, and they built more and more options on it. So what you see is a main spindle on the left, and then the multitasking machine comes from the fact that there's a true milling spindle on the turret. Where here usually you would see a turret, you now see a milling spindle that can actually rotate what we call a B-axis.
Yeah.
So often they're called a B-axis lathe as well.
Yeah.
So it's a true 5-axis milling machine.
Yeah.
As the turning spindle can be used as a C-axis or as a turning spindle. And then this one's taking it a step further. So you've got a sub-spindle as well, which can be used as a C-axis, so full 5-axis simultaneous on the sub-spindle. On the
sub too.
As well. And then a lower turret for turning. So for especially very rigid turning, so you've got, it's easier to take deep cuts on this than on your milling spindle because it still needs to be clamped and there's more bearings you see. And speed, because tool changing on a milling spindle is a lot slower than on the turret.
But so this is crazy because that's what I would think of as a traditional end mill in a milling spindle. But if you open, what was it, one of the doors here? It's a Capto spindle, so it's a Sandvik style spindle. Instead of being like a Cap 40 or an HSK, that's the spindle taper, and you can hold lathe turning tools in the spindle and do turning out of that spindle. It's incredible. That's one of the silent tools?
That is one of the silent tools.
It's amazing.
We've got. So this is 32 diameter
32,
rod.
Yep.
So we use this for the minimum bore diameter is 45 millimeters, I believe, for this, and it is 160 millimeters long that you can do.
Yeah. So yes, 5.
So it's 4.5 times the diameter.
So you can tip your head to 90 degrees and come in and do ID turning with that.
Yeah.
That's awesome.
We could actually just, to show, change one into the spindle, which would probably be a cool thing anyway. We'll close it up.
Automatic door. It's an amazing machine.
Let's see the one we want. It's tool 33. All right. So by default, we need to be in this angle for it to measure it on the presetter, on the arm.
Yeah.
But for turning, you can use it this way.
Yeah, look at that, look at that.
Or when you're machining on the sub spindle, you use it that way. Now you are going to say to me the tool's upside down.
Tool's upside down. Look at this, look at this. Tool's wrong way. You just reorient it.
Up, and it's done. So you flip the tool depending on which side your machine is.
And so when it does that, it's actually locking. It's locking the B, but it's also locking the spindle rotation as well.
Yes, there is. Essentially, there's like 3 brakes we would have to think about. There's one, just a disc brake for the B-axis.
Okay.
So you can lock on any given B-axis rotation on an increment of 1/1000th of a degree, something like that.
Wow.
And there's a curved coupling, what they call, on the B-axis, which is 12.5 degrees. So every 12.5 degrees, you've got another brake you can push in.
Oh,
so
wow.
use specifically for the turn-in. So turn-in you use on 0, 45, or 90.
Yeah.
Especially the 45 is convenient if you do not have a lower turret, because then you're not having any trouble with the spindle touching anything.
Yeah,
So the clearance is very important for that. And then the spindle rotation, so like the milling spindles rotation, you have to lock. And there's different kind of systems for different multitasking machines.
Okay.
But the Okuma essentially just has a gear and uses 6 teeth to just lock the gear in place.
Stops in place.
So the spindle cannot rotate at that. So you can only lock it at certain intervals.
Got it.
But usually you use it at 0 and 180 to flip the tool around for a main and sub spindle. And if you've got like a multi-tool, you could.
Like the Prime that has rougher and finisher in one.
Yeah, but essentially that's still 0 and 90, but you've got like tools that have 4 heads on one side.
Yeah.
Rob Lockwood has one,
for
example. And then you would need 4 different rotations.
It's like a Christmas tree, like your CMM Pro, but tools.
Yes,
that's
like
crazy.
that. You've got those 2, which you can essentially easily set up here as well. Great thing about this machine is that it's collision avoidance system, so you can actually see the whole
That's great.
machine.
That's the live view right now.
Yeah, so actually, if I start moving the machine around, let's see if we can do it. It's actually an X going down. It has one issue, essentially. It means that in jog mode, you can only move 1 axis at a time.
Ah, I see. Okay.
But for anything else, you can of course move more axes. But it's actually a live view of what's going on. So it actually knows what is going on in the machine, and it stops you from crashing.
So when you post code out of Inventor HSM into this, do you run a pre-check to have it run through the program but not actually move, or does it just do in terms of collision avoidance, or is that more real time during the operation?
I can actually just run a simulation, which is quite easy, like at full calculating power of the control.
Yeah.
But it's still quite slow because it's got to move all these models around. Like, any form of collision control usually is pretty slow, even like if you have complete.
Yeah.
It is fast, like I'm not bashing on complete here, but just the amount of data that needs to be compiled is a lot of work.
Sure.
So the Okuma does 2 things. Like it first checks that when you load in a program, it checks if the code is actually correct. So if you would like change a G01 to a P01 and say this is wrong, it will throw it out even before you loaded the program. And then the simulation for smaller parts, they just tend to do the simulation here, make a run. For the complex parts, they usually take so long, so we just start the program and do it live while the machine making the part.
Got it.
You're here in the 5-axis right now, which is probably a tricky thing because we cannot show that part. But it's just machining an aluminium part, but it's a bit loose in the vise, so that's
a little bit of noise.
That's the noise.
Interesting. The cell, the sort of like octagonal workstation here in the center of the shop. I like that.
Yeah, we when we moved to this shop, because we've had like this is the 3rd location that the shop has been in. We moved to this shop. We said like we need a simple way to program and still be able to keep an eye on the machines. So we chose workplaces for everyone so they could keep an eye out on their own machine.
I like that.
And now there was 2 guys with this table, so it was really massive, but we knew we were probably going to grow, so it kept the space. So we've got 4 workstations right now, so everyone has their own computer for their own programming and machine. which is kind of nice because if you're programming everything through CAM, you need to be able to access it all the time. Whereas a lot of companies have 3 computers for 20 machines. So if everyone programmed their own part, you're always waiting for the computer to be free.
Right.
Which is a machine standing still, which we don't want.
Well, that's a big end mill.
It's 20 millimeters.
Yeah. It's a strange looking coating to me. Is that coated or?
Yeah, this is coated. Yeah.
Interesting.
This is what the WNT guys call the silver line.
Yeah.
They were originally designed for stainless, but it seems they work great in a whole lot of other things too. So like now they've kind of become a multi-purpose tool.
Cool.
Something you see there as well is that everyone's got their own
the holders.
Torque screwdrivers.
Yes.
That's the thing. We used to have different ones, like one that you could set the torque to.
Yes.
But it means that if you've got 1 or 2, you constantly have to change the torque.
Right.
Constantly have to change the bit, which means that once in a while you use the wrong bit, you break the screw again. So everyone's got their own set right now that they need a lot.
The idea with these is you rotate it until you feel the grip in the handle start to flex.
It clicks.
Oh, actually. This does click.
Yeah.
Oh, okay. Okay. I've seen some of the more cheaper budget ones where it has like a soft rubber and you basically turn it until you start to feel the rubber flex.
No, this actually clicks.
Cool.
These essentially, I believe, are Vera tools, but in Sandvik
colors. Yeah, right. Yeah, so here's more of that. It's crazy. This is that Capto style. Capto's numbered, so this is probably a C3.
This is C3,
yeah. But that's your, actually it looks like the tool that we use, that grooving, 2mm radius grooving tool. Maybe that's 3. But yeah.
This is 2mm radius.
Okay, yeah, same one. That's awesome.
Yeah, so we've got all the lathes set out completely with Capto tooling.
Okay.
Just for the sake of changing a tool from one to another really quickly, and secondly because it's really rigid. Like comparing it to just a straight shank, this is a more rigid solution.
Got it.
And you can really easily take out a tool and put a different one in. So when you're never doing the same thing today and tomorrow, it is really nice to be able to just change tools really quickly.
So it's a standard Doosan turret, but you buy these Sando Capto bases that let you put the Capto into each spot.
Yeah, so what you see here, like the driven tools here are still non-Capto, which is just an ER collet essentially.
Okay.
So they're not from Sandvik.
Yeah.
In the Okuma machine, we'll see that there are Sandvik ones with Capto, the driven tools too. But indeed, you've got the bolt-on turret, and then you bolt the Capto.
Yeah. It just lives there
locked
forever.
To it. Yeah. This usually lives in the machine. We don't change those a lot. But the idea is that you use a torque wrench the right way.
Pull it out.
You got your tool. You can change any other tool directly through in there. Then you can just put it back.
And it will repeat as well.
Don't quote me on this, as I'm.
Well, you are on video.
Not a Sandvik guy, but I believe they say it's within 3 or 5 micron.
Yeah, incredibly accurate.
Yeah. So probably some Sandvik guy's gonna get mad because it's 2 micron, something like that. But for us, essentially, you see people buy roughing like the tool twice, 2 roughing holders, and just exchange them and without setting a different offset.
Yeah. So they change inserts offline, basically?
Yes.
Oh my gosh.
So, because it's much quicker to change the whole tool than to change an insert while the machine's stationary.
Right.
So you just change the tool and then change the offset.
Well, I like that because it gives you time to inspect the insert in the pocket and take your time and not feel like you're rushed to get that insert rotated.
Yeah, so that's something you could do with this as well. We don't often do it, but there are times where it makes sense, especially when you're doing parts where you need a lot of bits. Like if you're machining weird materials, you'll see that often
you're just gonna let me walk by this universal
I was gonna
robot
just let you walk by this universal
and not
robot.
talk about it?
Yeah, it's one of those projects that we're all talking automation, but like for the past couple of years, and this was our way to get into that. So we bought the universal robot, designed this whole cabinet ourselves, so it's not.
Oh wow!
Nothing's bought.
Okay.
Everything's designed by ourselves, and it actually works with this machine. It works with the other lathe as well. So they're both. It's connected to the machine. So the moment the machine says, "I'm ready for the part to be taken out," it gives a what we call a robot call.
Yeah.
And then from that moment on, the robot controls the machine. So it moves in, grabs the part, tells the machine to open the chuck, and tells the machine to close the chuck, close the door, and then is ready to go again. So we all program straight from here.
Yeah, that's awesome.
It's off right now.
Yeah, but the idea is you can have multiple parts stacked up here, and it can open and close the drawers to get. Can it reach all the way down here?
Yeah, essentially what we do is we move the drawer. All the full drawers are on this side, and once it's done with the drawer that's currently being used, it pushes it to the other side, and it shows the new drawer here. So it moves totally down, like to the lowest drawer if you pull that here. Let's see.
Right, so I mean more parts, a lot of parts.
A lot of parts. I believe this restaurant is 80 parts by default. So we use one part per square, but we have different tops for this. So if you have smaller parts,
that's right. I see. It's just bolted on.
Yes.
Got it. That's cool.
So we can just change these to have smaller squares where you can have more parts on, and it's just a parameter in the program. You say what's the difference between this corner and this corner. So it works pretty easy, works pretty well. But it's still a lot of work if you're doing 5 parts.
Got it.
If you're doing 5 parts that are done in 2 minutes, just setting up the robot usually takes longer than just putting them in by hand.
Yeah.
It's a little quiet in the shop right now because everyone's at lunch, which gives us time to actually see all the machines and open up doors, so that's cool. Like we saw with the Okuma, all the machines got eco mode, so all the lights turn off.
Oh, interesting.
All the hydraulic units turn off.
Wow.
So especially the Okumas, they have it's pretty advanced, as in once you get out of the eco mode, it takes time for all the hydraulics to be powered up back again. So it takes like 30 seconds to get out of eco mode. This one's a little quicker, but it still does that just to save power when you're not using it.
Wow, this is a big lathe, or actually pretty long between centers.
Yes, 1250 millimeters, I believe.
Yeah, that's 50 inches or something.
Yeah. So, well, we've seen the 3-axis mill, which was our first proper CNC machine we bought. We'll see another teach-in lathe later. We'll explain about that. That we got first. And then we had another teach-in mill at the shop, but that was the first proper CNC machine. And we bought a used DMG CTX lathe with live tooling. It had a whole lot of hours on it. So it was cool for us to learn how the machine worked, but it was on its last legs. When we bought it, we knew that. And when we had to replace it, we were such big fans of the 3-axis milling machine from Doosan that we went to this one. So this was for us,
your first turning center.
Our first turning center that, so it was bought new, delivered to our shop. I think we've seen the printouts of the paper before. So I think this is now 5 years old. So this has got the same Capto.
Yeah, same thing, Capto, huh?
Yes, but what you see here is the Capto C6, which was
bigger.
Yeah, was originally not made on this machine by Sandvik.
Okay.
But we wanted the bigger drills to be able to use them in this machine as well. So we actually, you could see it on the Instagram, actually machined this adapter plates between the turret and the standard Capto block.
Yeah.
Because these are all designed by Sandvik to fit on a specific machine.
Right.
So you buy a Capto C4 internal turning block for a Doosan Puma 2600 with this turret.
Yeah.
So since they don't do that for the Capto C6, we made this. 2 months afterwards, of course, CNC thought, that's a good idea. We'll make those two now. So now you can actually buy them. But
and that's a Shunk, a steady rest.
Steady
a
rest,
follower.
yes.
Yeah, that's awesome.
Yes, and it's
Cool.
They call it a programmable steady rest. So it's not servo driven, but we can use the turret to move this around in program.
Cool.
So
you literally drag it around?
You can see here, there's just
oh, the little drive dog.
Yeah, so if we now push it,
oh, that's cool.
This should work. Oh, that's good. You see it come up.
Oh yeah, look at that.
And then we can actually just use the turret.
Look at that.
To move it forward. Let's turn it up.
I love it.
So while it's not servo driven, you can move it about in your program, which is really nice because there's a lot of parts where first you need it to be in the front, out of your way, and then afterwards you need it where it should be used. So and the same goes for the tailstock.
Uh-oh.
Oh. You can see I'm not running this machine on a daily basis, so I pushed the wrong button, but that's...
Oh, you're done with that job that you were just running this morning, huh? You sure you already pulled the jaws off? Cool.
Yeah. So they already pulled the jaws off, probably figured out which jaws they need to set up the next job.
Got it.
And as you see, there's usually a lot of different jaws ready. We now engrave what size they are.
Oh, I like that. The diameter.
Yeah. So it's 80 millimeters this. Many people would say, why do you not engrave the part number you made them for in? Because 80 millimeters is quite a common size. So it's not necessarily tied to one product, it's tied to a diameter of part you can clamp with it. So you see a lot of different ones we've got. Some pretty big things we already turned. These still need to move to the 5-axis machine.
Got it.
To be finished.
What's the material?
It's a sort of stainless.
Stainless. Wow.
So I'm not actually sure. Like, there's not a name like 316 or 304. It's a number like 1.4755, if I recall correctly.
Parts.
Yeah.
Oh my God! Look at these. Holy cow! Can I pick one up?
Sorry?
Can I pick one up?
Yeah, of course. Just pick one up. No problem.
Oh my God! Yeah. Look at that thread. Holy cow.
So it's an M48 thread.
M48?
Yeah. These are parts we make and designed together with a local company for towing trucks, actually. Not throwing them. That would have been fun too, by the way. But
throwing trucks?
Yeah. But so these are used to tow stranded trucks as far as just mechanical failure.
Yeah.
But also when they've had a collision and they're really not able to drive anymore. Yeah. They can lift the whole front of the truck up and just drag it along. So that's what we make here on the Okuma lathe.
Oh yeah, there you go. That's what goes in. It's funny. I mean, that's a pretty big part. This is a pretty, I guess, next to the large 5-axis and the Multus, this looks like a smaller machine.
It is a smaller machine in footprint too, but it's capability-wise, it's great.
Yeah, you like it?
Yeah, it's been fantastic for us.
There's the threading. That's something crazy on a Capto. There's your threading insert. Oh, that's awesome.
So the holes we drill with are with the Capto drills as well. So with the live tooling. So
wow.
So this drill,
that's an 880 drill. Or you drill. You're drilling those holes on a driven tool. Wow.
So on the other side is like this is a 30 millimeter one, and the ones going in is already 21 millimeters. It's 4 times the diameter. We just drill them in the live tooling here as well.
No problem.
No problem. And it's so this drill we actually do stationary in the machine. Yeah. Or in the live tooling.
That's funny.
It's funny with you after Capto you can just move things around.
Right. That's crazy. That's awesome.
So this same drill has probably been in the Doosan Puma lathe, and even in our 5-axis mill because I've got BT40 to Capto C4 converters. Yeah. So I use the same tools in the 5-axis as well.
When a tool like that is in a driven holder, you can't use it stationary, right?
No.
Okay. It would have to get moved into, well.
Yes, this one, for example.
That's stationary. Yeah,
this
got
is
it.
stationary.
Got it.
Yeah.
Right. That's cool.
So you would have to move it around.
Right. It's not like the mill turn where you can.
It does not have the same kind of clamping
right.
force to do that. No, no, no. But it is pretty cool to see, like, it needs to align each time before you rotate the turret. So it does, like, the machines are so smart to do that right now that you can just, you see that it turns the tool if it's been milling.
Oh, it aligns it?
Yeah. Okay, you just turn it to whatever.
Oh my God.
And then if you just rotate the spindle with the turret, it aligns it each time.
That's
so
cool.
So now it is stuck.
Yeah.
Like it is stationary right now.
Right.
Because it has to do with the coupling in the turret to rotate the tool, of course. So you see, like, making the center point, we do stationary, which is in a stationary tool. But it could have been in a live tool anyway.
Yeah.
Yeah. We tend to do it in a stationary holder, because it means it's at least centered, even if it creates a little too big or a little too small, it's at least centered with the spindle. Mm-hmm. On the other hand, if the parts get real big and you're scared that rotating it will cause it to fly out, you just use a live tool drill.
Yeah, right.
And so this is with a servo tilt stock. So this moves around just on its own servo. That's why it's in the back now.
Got it.
And halfway through the program, because the center hole is not in before it goes in. So we don't have to do anything. You just put the part in and get the done part.
Yeah, got it.
That's
right.
So this is the teach-in lathe.
Teach-in lathe.
Teach-in lathe.
Okay.
With a Fagar control. So we've already seen the Okuma control, the Fanuc on the 3-axis, or actually 4-axis mill, and the Siemens control on the links on the lathe. This lathe with a Fanuc control as well. The other lathe also with the Okuma control, and this with the.
And the 5-axis has a Heidenhain.
Has a Heidenhain, yes.
Okay.
So this is one of the things that we say: if you're using cam, pick the right control for the thing you're doing. So for the 5-axis, the Heidenhain was the proper control to choose on a 5-axis machine. Mm-hmm. So you didn't want to be held back because you knew the Fanuc.
Yeah.
You've got a post, make the code work. I don't really care about what control it is, as long as it's good at what it's doing for that machine. So this is with the Fagar control, and we call it a teach-in lathe because you can actually do the moves and make it record it. So it actually just does the same moves as you do.
Right.
But we don't use it in that manner. We use it, you can actually just program on the control and make it just do cycles.
Pretty bare bones. You only have 2 tool holders.
2 tool holders, but you can change these easily. That's the idea.
Yeah.
So with the multi-fix, but only 2. So we use this one for drilling, put drills in, and this one for turning.
Yeah.
So especially like simple parts where you just have to face off, do a little turn, and drill a hole or center hole, you can do in one operation. That's why we make 2. And it's really easy. So we programmed this one mainly on the control, because you'll see you have different.
Oh, it has a conversational.
Yes.
Okay.
That's one of the main reasons why this is a great control for when you just have to finish off a part or fix a part. Someone comes in with, this is broken, can you change this diameter, stuff like that. So it's been a great control for that, and it's still in use. So this was probably like the first CNC controlled machine we've had. It's getting old. Yeah. But if it runs, it runs. Like
sure.
It's making money. So
what's with the HPs at every station?
Yes, everyone's got these.
Oh, they're tablets.
They're actually tablets.
Oh wow.
So you can just take
my gosh.
You can take off the keyboard and put it on that way.
Yeah.
Or if you're just using the touchscreen anyway, you can use it like this. And this is for our ERP system.
Okay.
The idea is that we should be completely paperless. Mm-hmm. Doesn't always work out, but so anyone can see what their current jobs are, what they need to do, what the next job is, for example. So this is the whole list of the guy running this machine. And and also their drawings are stored in there.
Got it.
So you got the drawings here, so you don't have to move a whole lot of paper around the shop all day.
Does this tie into Autodesk Vault that we were looking at in your office?
No, actually it doesn't.
Okay. Separate.
So this gives you the drawing number, which you could look up in Vault.
Okay.
But essentially you could install Vault on these tablets as well.
Okay.
That's not too
Oh,
big
there
a
are
deal.
these. Yeah, that's great. The longer Puma lathe that we just saw that had the steady rest, they were turning these this morning. So that center mark is just it's a cosmetic mark from the center, but it's a long part.
Yeah, really long part. So we get these in as tubes.
Yeah.
So we machine this bearing cavity here,
Yeah.
and then on the other side as well. Then we hold it onto this side, and on the other side we
you
put
turn the ID.
Yeah.
Got it.
And then we machine the whole OD in one go.
Wow.
So the whole thing is machined in one go.
Yeah.
And these are rollers for, we talked about
Thread mills.
So not thread milling, but for thread mills, the ones you walk on.
Yes.
So this is really cool. And they're no longer straight to keep the
Belt center.
the belt in
Yeah, they're
in
actually
center.
slightly curved. Yeah.
So you've got different versions. Some are actually concave or convex.
Vex would be a mountain, I
Convex,
think. Yeah.
And others just have two angled
Okay.
sides. It depends on the use, what version you've got.
I'm distracted.
What could you be distracted with, John?
You had a camshaft, I think, in your showroom or your lobby.
Yes.
Are you seriously going to mill a crank?
Yes. So we have the camshaft. We make those often. Right?
Yeah.
And there's two different ways we can do that. We can just do the turning,
Yeah.
or do turning and pre-milling on the lathe as well, which
That's
you've
cool.
seen. The one that's over there
Yeah.
has pre-machined. We pre-milled it as well, and now we've gotten a job where we're doing
A crank.
the crank.
That's crazy.
Yes, which is
So this is what it came to you as?
No.
You haven't done anything yet?
no, we got it as raw stock.
Serious? Oh, you
Yes.
did that turning.
We already did this turning.
Wow.
But we did this turning first because the amount of material you remove, you can actually see the whole thing wobble if you put it in the lathe now.
Yeah.
So we machined this first. So once we get to the milling part in the Okuma Multus,
Yes.
then we'll at least have all this material removed already, so we're not seeing that tension of the
Yeah.
material.
Did you have to send it out for normalize after you turned
No,
it?
we're not doing that right now. If this works out, we'll probably get bigger quantities, and then we might look at
Got it.
things like that. On the other hand, like with the camshafts,
Yes.
they usually don't. You just machine them in one go,
Mm-hmm.
and then they just brute force them back into alignment.
Oh,
So
really? Got it.
there's multiple ways to get to the end
Right.
anyway.
They still get ground, or is it a finished machined product?
No, they still get ground. At least
Okay.
for now, they still get ground because there's people great at doing that.
Yes.
But essentially, if the quantities will allow for it, and the Okuma Multus is capable of putting in a grinding stone and grinding them on the machine.
Yeah. Well, and the more accurately you machine them to net shape, or the final,
Yeah.
the less grinding you're going to have to do. I
Yes,
guess.
which is of course always a struggle between the one machining it and the one grinding
Yeah,
it. Because now if someone else grinds it, the thing is you're like, I don't really care if there's a little more in the corner, yes or no. Whereas the grinder will probably not like that very much. But if you're doing all of it, that helps.
Yeah. That's cool.
Yeah, so that's pretty cool. So that's a job for next week, I think.
And you're programming that in Metro HSM.
Yeah, so
Yeah, or
essentially in Fusion.
Fusion. It's awesome.
And
And you run the Multus on Fusion effectively, or HSM.
Yeah, it doesn't sound as fun if you say I'm running it on Inventor HSM.
Right.
But essentially it's the same thing. So we're running this very expensive multitasking Okuma machine
I think it's awesome.
straight from Fusion, which would be $360 a year.
Yeah, right. 500 a year now.
Oh, 500 a year now.
Yeah,
All right,
I can't keep track.
But still,
You don't also have NX or Spree or something else.
No,
you just
'cause
have Inventor.
It's one of those things that we tend to say, if the software I use is easier and quicker to program 90% of my parts, I don't care at spending twice as long at the other 10%.
Ah, okay.
So if most of my parts are programmed much quicker in Fusion than they would be, for example, in an NX, it's much better way for me to spend more time doing something really complex if I get to do that.
Yeah.
On the other hand, making a 5-axis chamfer in Fusion or in 187 isn't that hard either.
Yeah.
So you'll see our 5-axis machine do 5-axis simultaneous cuts at least 4 days a week.
Yeah. Okay.
And it doesn't really matter that it needs it all the time.
Yeah.
But just chamfering stuff usually saves multiple rotations and moving to a clearance plane, stuff like that.
Right. We're tracking.
So this is an old machine we're in front of right now, which is really cool because you move on, you buy more expensive machines and more accurate machines. So we're buying like this Okuma Multus, and in the same year we bought this I believe 17-year-old.
You bought this after the Multus.
We bought this after the Multus, which is really cool because we needed to make a whole lot of parts.
No, yeah.
And they're just aluminum parts, nothing fancy.
Yeah, you don't need a Multus to make that.
So the thing with that is that we needed a machine with a pellet changer, and we didn't really know if this type of business would suit us, doing large quantities parts. So we were like, get a simple machine, don't pay too much for it, and see if it works out. So it's been with us 4 or 5 months, I guess, and it's been great.
It's been great.
Yeah, it of course has had trouble before, but here you see the Lang as well. So here you see the Robo Vice, actually.
Oh, the new one that they can use to lift. Cool.
Yeah.
That's awesome. Yeah.
And there's a hole on the side so the coolant and chips flush through the middle outside. So we're moving towards these when we buy new ones, new Vices now.
Right before I got on my flight to come over to the Netherlands, I was texting Lauren about picking me up, and he's like, the YCM just let out a bunch of smoke. So I was really surprised to see it's still working.
Yeah, for some reason there was some smoke out of the electrical cabinet. So we cleaned all the filters up, checked it, couldn't find where it was coming from, and been running today fine. So we'll see.
Her days may be numbered.
It could be, but on the other hand, she runs great once she runs. So like,
it was great. We sat here and watched it, and so the operator loads the two here while the machine itself is that open?
Yes, you can rotate. Yeah,
is doing the work. Right here. It's a 2-tool, relatively quick operation, and then by the time it's done, he's already got the next 2 parts loaded, so they can hit the button that's going to cause it to rotate that dual platter around. Do a pallet change, up, spin, and back to work. Pretty snazzy.
Yeah, so that's essentially how the pallet change just actually works and can make you a part, which is great because now you can change the parts while.
Right.
I'll change 2 parts just so we can see it run.
You just center them up, eyeball?
I do.
Yeah.
We've got a guy usually running the machine. He has a tool for it, I believe.
I like to see a lot of torque wrenches.
We've got torque wrenches essentially for anything.
Everything, yeah.
Yeah.
And I love the Swiss PB wrenches, or PB Swiss, excuse me. These are awesome.
So let me do the pellet change first. All right. Because these are the ones that we changed.
Does it have a enough control space? Like, can you post adaptive to this?
Well, I believe it has 265 kilobytes.
Okay.
Which sounds little, but if you just store 1 program in,
it's not bad.
It's actually not that bad. I was kind of scared.
Yeah.
For it when we bought it, we were like, we're just doing prismatic parts, so we should be able to keep away from adaptive. But now we're just using it anyway, because.
Do you have it DNC'd?
Yeah.
How do you? Okay.
Yeah. Well, actually, a cool story. Because we had to make our own cable for it. So you see that
That's a little, that's hacky.
And there you see where it goes to is to a Moxa connector.
Okay.
So it's hooked up to the Ethernet. So any
even
computer in the shop can actually just send a program in.
Okay, so the cable that we are looking at here, I'll walk
Go
around,
the other way.
that had the cut wires connected right there is actually an old school, 25 port parallel, or oh no, 9. Like
Yeah, there it is, 25. Here it's 9.
Okay, okay.
And then we go to the Moxa N port series.
And then Ethernet.
Yes.
That's awesome.
So we can send the program like from any PC.
Not hard at all.
No, it's not hard at all.
That's cool.
So, one of those things that.
Oh, there you go. It's already cutting.
Oh no, I stopped it.
Oh, sorry.
No, no problem. There we go. So this is just drilling and chamfering the hole in one go.
Is that a custom tool?
This one, yes.
It is.
Because this diameter ring didn't work out. Because it's so close to the part.
Right.
So if the wall would have been a little further away, we could have used a standard tool.
Got it. Tool change, end mill, clean up the sides, and we're done. You said you were pretty happy with a 30 taper, or how its ability to mill, even though it's a 30?
Yeah, like people are like, you cannot go really beyond 12 millimeters, like half an inch tool. But we've run 16 millimeters, like 5 times diameter a couple times, and it works. Like,
yeah, so it's pretty smart. And they had a form tool or custom tool made that can do the hole and the countersink all in one operation, so it saves the tool change, which is a big deal on this.
And like the surface quality has been fine.
Yeah, it's absolutely great.
So nothing to complain about that. And then what you hear now is just blowing the pallet clean.
Oh, so that's a good example. Lawrence wrote a post processor, we just missed it. In the post, it looks at your CAD model, the stock size, finds the maximum extent of your stock, and does was it through air blast? Or cool?
Yeah, no, it's side air blast, but
side air blast that walks all the way around the part to blow it off. That way, when you get back to here, they said that was the better way to do it. That way your operators aren't spending too much time here blowing them off, and that you get behind on the machining.
Yeah.
Awesome.
So we actually just like wrote something, and it's just a post property you can turn on and off.
Yeah, right.
So essentially you can turn it off if you want to, but usually it's on here.
What is this stuff? Oh, that's your dot. That's your marker.
This is our mark.
Oh, that's awesome. That does the numbers.
Someone just used 3 for these jaws on your lathe are numbered, right?
Okay, yeah.
So the 3
we don't like lathes. I don't like.
All right, we'll go move along. No. So this is, they put in the 62 millimeters diameter and the number on the soft jaw.
Yeah.
Because not all soft jaws are numbered when you get them in.
Yeah.
Some are, some aren't.
Can we mark something? Scrap part?
We should be able to. Shouldn't be too hard,
I kind
right?
of want to see it.
So just gotten any aluminium part right now. Uh-oh.
Does it fit? Oh, you just drop it down.
It will fit. Because we're going to move it up.
You really do like those Langs.
So essentially it doesn't
Oh,
really...
you can leave it there. Oh, I see. Look at that.
We turn this one. And move it straight up. All right. Lock that in place. Could even probably stick it in the middle. So what we could do now first is do a test run without it actually...
To show where it's going to go?
Yeah. So let's see. Test all of the program. All right. So that makes sense. And then we just hit start.
That is awesome.
Easy
I really
as that.
like that.
So we use it for a lot of stuff. Also for serial number engraving, like doing incremental serial numbers, stuff like that.
Looks great.
Because you can set like the number of dots it uses.
DPI.
Yeah.
For us inch people. Did you say DPM? Dots per millimeter?
Yeah, usually, but...
what is it, centimeter? No, there's a decameter. There's something between centimeter and meter that nobody uses.
It's a decimeter.
Yeah, decimeter. No one uses that.
No, no one uses that.
Yeah.
But
I'm trying to find flaws in the metric system here. Work with me.
yeah, but it works. You need it if you want to calculate liters.
Oh, really? Yeah.
Because 1 cubic decimeter is a liter.
Oh, is that right?
Yeah.
Okay.
So that's probably the only time I use a decimeter.
Oh, holy cow. Look at those racks. Second shop tour where I've said, I like your rack. You built these?
We designed them.
Had them built.
And had someone else build them, because we're not really fabricators, we're more machinists. So we got a couple of shops nearby that do this kind of thing. So we've got storage, usually centered around one type of material.
Okay.
So you'll see 304 stainless here, 316 stainless there.
Okay.
So
it's always the trick. Do you try to do the color coding, or is that just a coincidence from whomever you're buying it from?
it is a coincidence from whoever you buy it from. But since we've got like our two main suppliers here, so you can see the actual.
Try to figure it out.
Yeah.
Yeah. Oh wow, look at that. Yeah. It's never easy to keep track of your drops.
Yeah, so you got, and here we've got a whole lot of small.
Right.
These are the kind of things that, or you throw them away if you don't store them correctly.
Recycle. Yeah.
Yeah. So you want to try and, because there's always going to be something that's small that you still need to machine. So try and keep track of that.
Yep.
So try and keep a lot in stock, because a lot of our customers need for it essentially yesterday.
Yeah.
So when they need it yesterday, it's good to have something in stock we can work with. So we try and keep a lot in stock to actually make them apart quickly. And then a lot of different materials, so we can actually support all of them. So getting to the tapping. Yeah.
Cool. Oh, I like having the chuck mounted. That's slick.
Check on it. Lang plate over there.
Oh my God. A lang plate for this vise? That's hilarious.
This vise actually is able to go on our 3-axis and 5-axis
Oh,
mill
really?
too.
Wow.
So
Holy cow.
I actually put the Lang studs in there for the 3-axis machine.
It's funny.
And then it's moved here. So I got 2 of these actually.
Hilarious.
And this is cool because you can actually push the part through.
Oh, it's brilliant.
Yeah.
I love that.
We use this a lot.
Plus, it lets you keep a chuck mounted, but not all the way in these.
Yeah.
Yeah. I'm stealing that.
Which is great, especially with this machine. You can set the depth.
Oh.
So you set depth, so it's like
That's
semi-automatic.
Cool. Yeah.
Let's see if someone's set it up.
Oh, wow.
Yeah. Turn it on. So we'll just do the number of rotations going down, and then do the same number of rotations, like the same number plus 2, I believe, going up.
Yeah,
you can set that up.
And
we've got, of course, the Engraving and Frank thread sizes all there, so it shows you the pre-drill size, and you can know what pitch to set, because you need to tell the machine the pitch, of course.
But the same thing with a clutch out style collet.
Yeah, so these actually slip when they get to the bottom of the hole.
Yeah, yeah.
So
you can adjust the tension.
Yeah.
Okay, so regular bandsaw here, but the other one is automated?
Yes, exactly like that. So in the back here, you also see our air compressor.
Oh, wow. Wait, I thought there was an air compressor above the Okuma.
There is an air compressor above the Okuma. That's actually our old one and backup. So we keep it as a backup.
Does it turn? Is it on?
We turn it on right now because these screw compressor you need to have on for longer periods of time. So you cannot just turn on and off all the time. So we run it like once in the month.
Okay.
Just run it a couple of days. So it works too.
Yeah.
But it cannot keep up with all the machines in the shop anymore.
Wow, that's some big material. Holy cow, look at that blade.
So this is the automatic.
That's a real
bandsaw.
deal. Holy cow.
We've got
So, but you could have stock delivered to you on a pallet, you know, pre-saw cut.
Yeah, we could.
Yeah, but
essentially you pay for someone else buying the same bandsaw and doing the cutting for you.
Got it.
So it kind of depends on the time we've got on the bandsaw.
Yeah.
And the type of material, because of course, if I would have to saw 5,000 pieces out of titanium, this is probably not the best way to do it. But we originally bought it specifically for doing those jobs that came in today and needed to be done tomorrow.
Yeah.
And we needed a big saw, so we were looking for this, and then it went for the automated one because it was a little extra and you could do it yourself. So, but now we see that we use it on a daily basis for parts, quantities of 50, for example, too.
Yeah.
So you just let it run.
I like the little stair steps that keep the parts from just dropping too quickly.
Yeah. So this is actually made by us, because usually you'd have just a slide down this way.
Yeah.
But they didn't fit in this shop anymore, because it fit in the other shop.
That's funny.
But it didn't fit in how we set this up now. So one of our guys designed this, and a company down the road does sheet metal.
Yeah.
So just down the road, we send the file
funny.
got it back. So that's pretty cool. This is one of the other robot projects.
Wow.
We
Yeah,
had.
look at that.
So this is kind of the same idea as the one we see in the front.
Yeah.
Currently it's being used as storage because it was in the way and we used it. But it's still being planned to be used. We bought an old KUKA robot.
Oh, really?
And we got a company to put new drives and control on there. And we got to the point that it was next to the machine and loading parts, only it wasn't accurate enough in picking up the parts. So what happened is that you would get the part and it would get caught behind the top, and sometimes it wouldn't be able to put it correctly into the machine.
Yeah.
Because robots essentially are designed to do repetitive work accurately, so their repetitive accuracy is pretty good, but their absolute position accuracy is pretty lousy for the older ones. The newer robots get better and better, so we try to do it a cool and maybe cheaper way, but it didn't work out. So we sold the robot, because why keep it if it's no use to you? And so we kept this, so we have a plan on buying a new robot and putting a new cell together. But it's one of those things that you get so busy that you don't take time to do that. But that's the same thing for most shops, I guess.
Yeah.
Like you guys see that too.
Yes. It's good to not take on too many projects.
Yeah.
Yeah.
But you see with Ed with his milling machine, like
right. It's fine.
It was a good idea, but it takes too long sometimes to get it to the point you want.
Can we go see that CMM?
Let's do.
Oh my God, hold on, you gotta see that drilling. That's amazing. Live tool, driven tool drilling. Amazing.
Probably one of the only machines that doesn't have an automatic door yet.
Yeah. Funny.
Yeah. Usually the automated door is of course a package you do with when you get a robot.
Yes. Oh
or
yeah.
Anything.
The robot can open the door sometimes.
You could, but it's slow.
Oh.
So why would you?
Oh.
Especially since an automated door is not that expensive.
Cool.
Should get this running back in a minute. Should be good. So this is probably our last major purchase, the shop floor CMM. We got a shop floor version because it's not a completely temperature controlled room. So that's why you see the SF at the end, shop floor, pretty easy. It's able to cope with vibrations as well. So essentially you could have put it next to the machine.
Got it.
But the more accurate the temperature stays in your room, the more accurate the machine is. So we'll try and, like, that's why we put it here, so to try and keep it as good as possible. Air conditioning is broken, so
Yeah.
still got to get the landlord to fix that.
Quite cold today anyway.
So no, it's fine. But it has temperature compensation for stuff like that as well.
Okay.
So yeah, and this has been a game changer in seeing how you machine a part and how it comes out. As in, if you turn something on the lathe, you expect it to be a round part.
Right.
But since you put pressure on it with the jaws and you pull it out and you put it on the CMM, you can actually like take measurements. I believe the last part we did 3,000 points on the circle. You can actually make it display how round the part actually is, and then usually you see that's a triangle.
Yeah,
like,
where your lobes are from the jaws.
Yeah.
That's funny.
So you can actually see stuff like that. Whereas you can measure that a little bit with a 2-point mic, but it's hard to give a number to it.
Right, and you don't get that pictorial view graph of exactly, yeah.
So with that in mind, this has been great to actually see what you're doing. Say like you guys always talk about, get some way to look closely to your part or closely to your tool. So in any way, or just use binoculars to look at them, but in any way to get a better feel for what's going on. And this is a great way for us to do that. And it's, of course, it's really accurate. So it's easy. You can put the part in, walk away while it's measuring. So you set up the next one, change the tool, something like that, come back in, see if the part's correct, yes or no. Yeah. And then...
so it has its own sort of quote-unquote CAM software. So you bring a solid model in and then sort of pick the points you want to measure? Yeah,
you can go like 3 ways. Essentially, you could buy something like Power Inspect, which would override the software that comes with the machine.
Who makes Power Inspect?
Autodesk.
Oh, okay.
Yeah, it's the inspection software that you would bundle with PowerMill.
Got it.
If you want.
Oh, okay.
Or you use their own system, which is
PCDMIS. Okay, yeah. Got it.
And you can get that in a couple of flavors, like with CAD or without CAD. So you can. A lot of stuff we program without the CAD because you just make features as you go.
Okay.
So you can actually, if you have the CMM and we just start a new program. Oh, first we have to close this one up. Start a new program and say test. Fine. Yes. It's gonna ask me what kind of material we're actually inspecting because it's got to compensate for the thermal growth of that material too.
Wow, that's crazy. Relative to the base, relative to where it's mounted.
Yeah.
Wow.
So you see temperature sensor here too.
Yeah. Look at
that. So that checks the table and current temperature. So we can actually compensate for the growth of the part as well.
That's crazy.
So in this case, we would just say iron, because steel is not an option, so they call it iron.
Okay.
Then you tell it which probe you've got, which in this is what we call star, and then we pick any of the actual probes we've got. So we picked east, north, west, south, east. So that works. And then we can actually just move it by hand.
Yeah, I like the jog stick. That's kind of cool.
So turning it left goes up, right goes down, and then X and Y is pretty logical. You need to stand in front of it like that, because if you're like this, you make it hard on yourself. That's the thing.
So can you do this? Can you program this like the Fagor, like a teach mode on the part?
Essentially, what I'm gonna do now is you gotta be in slow, but you can just run it.
Oh, you're just gonna hit the part. Okay.
Into the part.
Yeah.
And then I'm gonna do it on the other side as well. Run it into the part, and then move it to the side a bit. All right, I've done 3 points.
Yeah.
3 points defines a plane. So I say, all right. Now it just gives me a triangle. Says we've defined some kind of plane. With the CMM, the most important part is alignment, as if you're measuring like 2D, just a circle, which is essentially a 2D thing.
Okay. Yes.
If the part is in at an angle, and you measure this hole, if it's straight, you get the correct size. But if it's at an angle, you get a smaller size because you measure it wrong. So what we call alignment is telling the machine if the part is in crooked, yes or no.
Well, and so can software correct for that?
Yes.
Okay, that's awesome.
So essentially, it works the same as with your 5-axis machine.
Yeah.
That moves the part about, but this just does it.
Value calculations, adjustments. Got it.
To do the same thing.
Sure.
So with that phase, we would normally just now say, all right, this plane we've seen is our z-axis plane. So z is from that, and then you usually set one line for the y and axis as well. Usually a point, so you've got a 0 point, for example, here on this corner. And after that, you just make a program. Yeah. So I can tell it probe a plane, probe a hole, stuff like that, or just 1 point and measure from point to point.
Right. You could measure squareness and perpendicularity of the outside features of the block, angles,
yes,
anything.
Like essentially anything, because.
Can this style machine drag, like stay in constant contact? It can.
Yeah.
Oh, that's really
so
cool.
It can stay in contact, and that's the easiest way to get a nice reading for roundness or flatness, stuff like that. And then you get the nice graph with it. Yeah. So that depends on the probe you've got.
Okay. You mean not the tip, but rather this section here?
Yes.
I see. Okay.
Because you can get the swivel ones as well. Yeah. And so then you wouldn't really need the star probe anymore. Right. But the problem with that version on the Tigo is that you cannot stay in contact with it anymore.
Okay.
So and we wanted that. And usually you can do a lot if you position your part correctly with the star probe and the other.
Yeah, it's cool. It does. Can you do a tool change? This is so cool.
We should be able to do a tool change.
I love it.
Let me see.
How long have you guys had this?
We've had this 3 months.
Oh, okay, quite new.
Quite new,
okay,
quite new.
Awesome.
But it actually gets used a lot.
Yeah.
Because it's so convenient if you're running a series of parts.
Yeah.
You just put the part in and get like all the measurements in one report. So it writes a report for you. Let's do a tool change to.
Yeah, we just got our tool presetter like 4 days before I left, and different than a CMM, but similar in the sense of like very, very integrated workflows around accurate measurements. Just happens to be for tools, not parts. It's amazing. Oh my gosh, literally, Jared, Ed, and I were all waiting at one point to use it. On the second day.
Use it.
No, but like we were all wanting to use it, not like
Yeah.
We actually had work to do on it. It's awesome.
It's so cool.
Yeah, it's fun.
So there we go.
Oh my god, I love it. Yeah, card here to the factory tour we did at Q-Mark, where they make all the different styles of styluses. So you've got different tip materials, you got different shaft materials. You can be carbon fiber, and they can be carbide, and they can be steel. Because some of the long ones, you have some real gravity affects them, especially if you just start tilting up sideways, and you have to factor that in basically.
Yeah, but not only gravity, just deflection.
The weight of it, yeah, sure.
And of course, deflection you can kind of calculate with. Like
account for.
Yeah, if you set it up correctly, it knows the type of deflection, so that's fine.
Yes.
But anything else like gravity, stuff like that, gets pretty tricky.
It's cool.
When measuring.
Cool. Almost forgot making a titanium motorcycle part on the Multus, so we can take a look at that, and I want to look at your tool storage.
All right, let's go. Because just changed the carbide tool on the Multus.
Okay.
So as we all know, with titanium, wears out pretty quick.
Yeah.
So
so cool.
Opened the door, put the new carbide tool in.
This is a Coro Chuck 930, so it's a hydraulic holder.
Yeah.
Okay, with a bushing sleeve, so 20 millimeter down to 12.
Yes.
Okay.
And on the other side, we've got the extension to it.
Oh, okay.
Because this is a 60 millimeter Capto C6 extension.
Okay.
Because otherwise we wouldn't be able to machine right past the chuck
Oh,
of
you
the
don't have
machine.
enough travel in Z.
We have enough travel in Z.
We
But
can't clear.
Yeah, because we need clearance from, let's see,
It's amazing.
because otherwise this side of the spindle would actually hit.
Right, it's huge. Oh, okay.
This is huge, and this is pretty big compared to the diameter of the part we're making.
And you don't want to stick the part out further.
No, because
Yeah.
it's already sticking out pretty far.
Could you put a live center in your turret and stabilize a part with a turret?
We actually have one in right now.
Oh yeah, right there for the, okay,
Yeah.
got it.
So I have the same for
Look at that, it's just Capto, that's awesome.
yeah. So it's Capto C4 on one side,
Yeah,
and you even have the. You see how far you press it in with how much force you put on?
really, that's the colors.
Yes.
Huh,
So if you've gone like past the yellow, you see yellow is 0 to 250 DHM. But it's sort of then the yellow's just gone. You're at green, so it's 250. Which means that I can actually see if it's engaged properly.
yeah,
But what we actually do with the lower turret, if you use it, you make it go to a certain force to actually have a repeatable system every time. Because you could say I machined the center point in the machine, so it should be the same.
yes.
But if you're using the force anyway, you could also machine the center point somewhere else, put the part in,
Cool.
and still get the same pressure on.
That's awesome.
Because if you just put
It's
send
smart,
it-
it knows the pressure from the turret. You don't need that sort of a tool there.
no,
Yeah.
because the pressure, you just see the load on the servo motor,
Yeah.
and it reacts to that.
That's cool.
The same as with a stock transfer. You program
Oh, awesome.
to a certain point, but once it finds a certain load, it says, all right, now I'm fully engaged with the part, now I clamp down.
Cool.
And that way, even if your facing is like 2/100ths of a millimeter off,
Yeah.
your part length is still correct.
Yeah.
So stuff like that really helps get a good part.
So here's what's funny. When you own a multitask, everything comes out of round stock. So this is a motorcycle foot peg,
Yeah.
okay, out of titanium, and they're machining it out of that piece of, looks about like 2-inch or so
Yeah, pretty much 2 inch
titanium.
So since we changed the tool, we got to measure it.
Okay.
Certain ways that we can do that, but we're going to do the standard way, the official way. Get the touch probe down
Got it.
and touch it. So first we need to call the tool. First things first. Tool 15 and so it's first pre-selecting the tool now in the magazine because I didn't do that up front. Door open, tool in. Turned it to 90 degrees already. So
Is the motor in that B-axis as well? The motor's in there too?
no, the motor is in the back.
Okay, so it comes through in a gearing system?
Oh, you mean the motor for the spindle?
Yeah.
Oh, the motor actually is in here. It's like a
is.
built-in motor
Wow,
spindle.
holy cow.
So that's why you need this size.
Yeah,
Because
got
the
it.
motor actually is in here. So we got the tool.
Yes.
Now we'll actually measure it. So get the arm down. So we've got one probe for the upper turret and one probe for the lower turret.
Okay.
We still call this a turret, even though it's a milling spindle.
Right.
but It talks a lot easier with the control because the control calls it a turret.
Interesting.
So just move it with the door open. Right. Flip the switch. So now we're going to see a funny thing. The control actually knows the arm is down.
Okay.
So you
oh, look at that.
So you
That's incredible. And you can there's a touch screen. Yeah.
yeah, so just touchscreen, so you can just move it around.
It is like the iPhone. That's incredible.
So it has a safety speed, of course, for with moving with the door open. Now the funny thing is, machine now calls me a collision avoidance system because it tells me that it will, if I move it down further,
It's gonna crash.
it's gonna crash into the probe.
Which is what you're trying to do.
Yeah, but not just in the normal feed kind of move.
Got
So
it.
now I open up my tool library and it says this tool I want, and it opens automatically the touch setter options.
Oh, I see.
And then we press down, and now it will actually move. That's it.
Oh wow, it doesn't have to do it twice.
No,
Wow.
does it once. I moved the tool back up. So the funny thing now is, I don't actually have to do it because it will do it automatically. But if you look at the holder, and so you can actually see it in real life what it looks like, then when you change setting auto set, you might be able to actually see the tool jump a little back and forth for the length.
The length, got it.
Because the length.
Updates.
So, and the moment I hit register here, you'll see that everything moves to 0 for a couple seconds, probably, or it's already gone. See?
There it goes.
And then back up, because the moment you hit register, it rebuilds all the tooling options you've got. It's a pretty amazing control.
It's an amazing machine.
Someone thought it was funny to actually like make a whiteboard on it, and then if you so you can remind someone to like
leave a note.
Yeah, to stay away from something like that.
Always leave a note.
Always leave a note. Technically, we could use the sub spindle to pull the part out, but since we're doing a low quantity here,
okay, so you use the foot pedals here. Can I do it?
Yeah.
Open the chuck. And that does.
So now it's open. You can actually move it out. So we need 132. See if I did it right. Push the pedal, like up until that smallest point. Looks good.
You got to break off. Oh no, it is off.
Broke off enough. Should be good.
Yeah.
And it's you can move it right now. It was in CX mode, but you can turn it right now.
Sweet.
Funny thing with the Okumas, I can do that on any machine, except for the Okuma because it give you a safety speed. So it actually set an alarm 8, which is emergency stop.
Wow.
So it turned all hydraulics off, put all brakes on.
Because I did that?
Yeah.
Wow.
I knew you were going to do it, so it's fine. But reset the thing.
This is the tool we're using?
Yes.
Wait, it's through spindle coolant?
Through spindle coolant. I use coolant on the outside as well.
Lawrence, this is insane.
We've got...
This is an expensive tool.
70 bar, so that's, I think, 1,000 PSI.
Yeah, it's high.
With enough flow to give a high pressure through the tool and on the outside. So we're also using the coolant on the outside. This is a Plura HD specifically for titanium.
It's like a $200 end mill.
Maybe a little less, but it's a pretty expensive end mill.
He was saying that they have these, they look like chip breakers, but they're actually behind the cutting edge, and so they don't stick, so the titanium doesn't stick to the tool as it wraps around, or as it cuts around.
Yeah.
It's crazy.
So it's not breaking the chip, because you'll see,
so,
especially like on the top of the machine, you got these real fine, long chips actually.
Yeah.
So it's not breaking those, but it's making sure the tool is able to get rid of them.
Yeah.
And we should actually be able to go for it. Press the green button. The door is so heavy that this one you actually, even if you don't put a robot or anything behind it, you don't want. And
you don't use the turret at all though on this?
On this one we don't use the turret at all because there's no turning.
Right.
But usually I could say general OD turning is always done with the lower turn. Just because of the tool change time, stuff like that. And it's real easy in Inventor to pick one or the other.
Oh really?
The way we do that is that in your tool library, when you set the tool...
Oh, just pick the turret position.
Yes.
That's amazing.
Just to say turret 1 or turret 2, when you power up the machine, it needs every door to be open and closed.
That is effectively a thread.
Yeah, you would say so, because effectively it's a winch for a rope. So
Yeah,
the rope would
cool.
actually run in this, and they need it to be this specific shape
Yeah,
to rotate it.
it's crazy. I'm trying to get the lighting. There you go. Yeah, it's incredible. And it's undercut. You said you did it as an undercut?
Yeah,
5
so
axis?
so it's, I believe, 96 degrees at certain points.
Yeah.
So if you see like at certain points, there's like really an undercut where you need. So we machine this side because it's not completely flat.
Okay.
We just surface it, all of it, and then the actual groove, we do 5 axis simultaneous, cut it from here to the other side.
That's awesome. It unwinds as it goes out, basically.
Yeah.
Yeah, right.
So this side we make first on the main spindle,
Okay.
and then we clamp it on the ID here.
Oh, on the sub. And so you're doing
On the
this,
sub,
this is
and this is machined on the
on the
sub
sub
spindle.
mill. That's crazy.
So
That's cool.
yeah, so with this machine, it really does not matter if you're on the main spindle or on the sub spindle.
Got it.
Like any program can be changed. Like you call G13 for the upper turret,
Yeah.
G14 for the lower turret, and within those programs you call G140 for the main spindle and G141 for the sub spindle.
Got it.
All other codes are equal.
Really? Oh, you don't need positive and negative directions.
All other codes are equal.
So it switches to Z positive, or drilling Z negative is that way for the sub and that way for the main.
Yes.
Right.
So the thing is that if you have a part, you would like want to make one on the main, one on the sub, at the same time.
Yes.
You could have the same program, just change the G140
Wow,
to
it
141, and it works.
That's crazy.
So it's like
cool.
with 5-axis machining, anything you can do on the main, you can do on the sub. There's a little less power on the sub spindle, so it's a different spindle motor, but the encoders are the same, so the accuracy is the
Got it.
same. And programming wise, it's great.
And the part comes out, it's being held like this right now. So you're roughing out around this part.
We're roughing around like this part is this is an angle at like 5 degrees from
Okay.
the way we hold it. So that's why we're roughing at being 5 degrees.
Got it.
To finish this part off.
Yeah.
And then afterwards we make this
Chamfer.
this pocket and chamfer.
Okay.
We do this with a smaller tool. And then we start on machining all the other sides, working our way towards the spindles. Because this will vibrate the most, so keep as much stock in there as possible, and then move to the other side.
Got it.
And then leave a thin slice and just break it off.
While that's running, can you show us some of your tooling?
Yeah.
How you store it?
You could just walk past, like turning inserts. We've got.
So you label, so individual bins, and then you label them, or try to?
As much as possible, like especially for the stuff we use on a daily basis and a lot, they all have a separate bin. Try and label them so I can keep track of what's being used and if I need to order new stock.
I got it.
So with things we do not use as often, or we have like don't need as much stock, we sometimes put more different inserts in one bin. So these are on the CNMGs, like we've got stainless 0.8 bits, stainless 1.2 bits, stainless steel, just like the steel bits.
43,
yeah, so try and keep it as common as possible that everyone can just grab one.
Are these the prime inserts?
Nope.
No, okay.
This is DNMG, so the prime inserts are one down. So the prime inserts are here.
I believe it. Yeah, like the jelly bean kind of shape.
Yeah,
Cool.
and it's funny because this was the original chip breaker they came out with.
Yeah.
And this is the new one, which like almost looks like just a shovel. You just But like here, there's a chip breaker, and then more. It's just real cool. That
works well.
Yeah, the simpler geometry works better for the parts we make.
Yeah.
So that's pretty cool.
That's funny.
But it got those in stainless steel, for example. So
Yeah.
you see the different.
And so you can get tooling inserts in 1 or 2 days lead time, generally?
Usually anything ordered before 6 in the afternoon is here before 11 or 12 o'clock next day.
Yeah, that's awesome.
Yeah. So we try and keep a little inventory, because otherwise if they run out, I run out. So
Right.
that's the tricky part, because you need to trust your supplier in keeping enough inventory so they can supply you and others. So that was turn-in inserts.
Oh, that's awesome. This was idle a couple hours ago, and now you're already back to running parts on it.
Just putting stuff on.
Oh wow, drills! Holy cow!
So this is just drills.
Oh my God, these are all carbide drills.
All carbide, through tool, through
spindle
tool,
coolant drill.
yeah, drills.
Holy cow! Yeah, the 460.
Yes, so these are usually we use most of the 460 because many machines run many different types of materials.
Yeah, the
So for
460 is the generic grade, or
Yeah.
cuts for any material.
Yeah,
from
so-
any material.
If you compare them like to the 860,
Yeah.
which are specific to or steel or stainless, you see probably 1/5 of the tool life. But changing the tools all the time doesn't really help tools. You'll lose one or two.
Yeah.
So we tend to run more on the generic ones. So we've got smaller ones, bigger ones. We try and keep stock of the most of the ones we
Wow.
use.
Yeah.
So this is
a
one of
good-sized
the
drill.
860s, 13.5, but we have bigger ones too. For some reason we stock the long drills somewhere else.
Okay.
I'm not completely sure why we didn't think it was a good idea to move these over, but these are the very
Are
long
you
drills.
serious? Really?
So this is the
Dude, that's insane.
30 times the diameter,
30 times,
30 times.
12 millimeter drill.
12
so basically a
millimeter
half-inch drill. Holy cow.
So this is
15
a
inch
30 times 7 millimeter drill,
Wow.
and this is a 40 times 6 millimeter. We got, which of course are also true.
Yeah, sure.
Tool. And,
Oh my God.
Not saying we're running these on a daily basis, but we use these long drills pretty often. And
Wow.
we use them in the lathes, on the live tooling, in the mills.
Crazy.
As long as you drill a correct pilot hole, they work splendid.
Yeah?
Yeah.
It's not stressful?
No, actually, like it used to be stressful when we first started with them because
Yeah.
they're expensive and
Yeah.
you don't want to break them. But
I want to see what the Multus is doing. Oh, it's back up to doing that. Okay.
so we're at almost 90 degrees because of the design of this part. This is actually at 98.908.
Got it. So this was a big change going to a multitasking machine, but I don't know, how hard was it to get comfortable? How long did it take you to get proficient?
Well, actually, like it always sounds weird because people say it's a very complicated machine, and I wouldn't disagree with it. But it's mainly like the way of thinking of how to machine a part, and
Yeah.
not necessarily how to run the machine.
The kinematics of it, yeah.
Because
Right.
a machine,
Programming is no different than
a
anything
machine
else.
is a machine, and the cam is the same. Like
Right.
setting your tool orientation doesn't really matter if I'm doing that on the 4th axis on that machine, or on the 5 axis there,
Yeah.
or on the Multus here.
Yeah.
Essentially, that's all the same.
Yeah.
So it's mainly getting to grips with how do I attack a part, which side do I do first so I can use the sub spindle to
Right.
finish it in one go, stuff like that.
Yeah.
But the programming is mainly down to having a good post,
Yeah.
which I did together with Akim, getting these kind of machines running in with Fusion.
Yeah. Yeah, because
and-
you have literally, this would be your sub-spindle program, right? You have two
and,
programs?
and lower turret.
The lower turret, got it. Right,
Yeah.
right. Two separate programs, that's funny.
Yeah, so whereas for the Multus actually it's all in one program, but once you call it G13, it puts it on the left side, and once you
Oh.
call it G14, it puts it on the right side.
Interesting.
So it's the same, it's one file.
That's nice.
Whereas for most Phonic machines, you split them out in 2 files, but essentially it's the same kind of code.
Got
So program-wise, that doesn't really matter for us too much. Once that's going, still gotta show like the amount of tabs we just keep in stock. So we've
I like the red bins. for
yeah.
this.
The only problem is that, like, since they're all PM tabs, essentially they're still like carbide.
Powder
so,
metal?
Yeah.
You don't want them to touch,
So
like-
you don't want them touching, but as long as they don't really move and you open a drawer,
Yeah.
it's one of those things that everyone's gonna tell you don't do it,
Yeah.
and everyone does it in the end anyway. So I know we'll get some comments about that, but
Holy cow! Oh, it's an extension.
yeah,
That's
so
awesome.
So we made our own extension for a certain part to drill a hole and
Deburring tool.
deburr it to and stuff like that. Because sometimes you just need to make a special tool. And so that's kind of how we try and keep track of most of it and be able to have inventory.
Yep.
So these are the special tap collets with the square on the back side. So that's why we keep them here and separate from the other ones. And of course, stuff breaks occasionally. So to make sure that we're not stationary, we try and keep stock of some of the items we use on a daily basis. So these are parts tools that we use and we really need for the production.
That's crazy. This is obviously Capto, yeah.
So even though we usually get them next day delivery, we kind of need to make sure that we're not waiting 12 hours of production time.
You know, it happened to us on one of our our drill bodies. All of a sudden, it was I don't know, 3 or 4 week lead time, and so we had to buy a longer version because we can't wait that long.
Yeah, stuff like that. So especially with these, because these are the Taylormade drills we've got. So it's a Coro drill 880.
Holy cow! Oh my god, that's insane.
Because Sandvik doesn't stock drills, I think, larger than like 42 millimeters on Capto. So so we store our own now.
It looks like it's an adapter there, but
yeah. So what they essentially do is have a normal drill, turn the thing down, and they have just these adapters laying around, and they press it in. And then now with the new ones, they've got an extra pin going through, where the old ones didn't.
That's a big drill.
It's a big drill.
What drill do you run? You run that in the Multus?
I actually run this in the Multus and in the Doosan Puma machine.
Oh yeah?
In the Multus I even tried it with the milling spindle, which worked.
Really?
Yeah.
Takes a lot. How many I don't know how many horsepower that would be.
I believe it's actually 26 kilowatts, which is times 1.3, so...
Oh wow, 40 horsepower or something.
Yeah, a little less, but something like that. But even other stuff like just having the silent tools adapters we use on a daily basis. We need this tool to move every day.
So a card here to the demo we did when we had a chance to go see the Sandvik factory, but these things are, I mean, they're very expensive, but amazing what they can do on the active dampening.
It makes it possible to machine a lot of the parts we do. Without it, it would take so long that you just couldn't actually start doing that part. So stuff like that we just need to keep in stock to be able to keep everything going.
Sweet.
Let's see if we can check out how the Multus is doing. So now it's facing the top of it, just using the same end mill in this case, just to finish it. And I think after this we'll be getting the next tool. Or maybe first finish the outside, that's still possible. Yeah, see, I run to the outside. So there we go for the next tool. So this is a 6mm But it's
Ooh.
essentially the same kind of tool from Samsung, for specifically for its titanium.
Yeah. Oh, it's doing that now, and we're doing the little bottle opener kind of section.
Yeah, so we make in the pocket.
Wow.
So could have drilled it first, but you can actually just ram down.
Right.
As long as you get the feeds and speeds right.
Yes.
It's not that tricky on the tool either.
Cool.
So it's like 60 meters a minute for the ramping, and then 120 meters of surface, which is like for the actual adaptive cutting moves.
Okay.
So whereas for aluminium you just say like max
Yeah,
RPM, be fine with it.
Right.
And with here you really, especially for the ramping, which is of course full engagement of the tool,
Yes.
you really need to lower the RPM. So just set that once and then it runs.
Cool. Awesome.
I kind of always love when we're walking around that everyone's working. Like,
Yeah, it's awesome. Machines are running. Machines are running.
so changing soft jaws
Oh,
there.
that's awesome. On the Lang system.
So this is just how the soft jaws look on the
Oh,
side
okay.
where you screw it on.
Yeah, yeah. Yeah, so these aren't that hard to make then. Good grief.
So essentially you just face them off and make these 3 slots
Yeah,
and tap 4 holes.
right. It's not a big deal.
Only thing you need to do. So there's another system that Lang has for this, and they say it's more accurate, but this usually comes out back pretty nice.
Oh, those look great. So they're done. Cool.
So even Lang chucks we've got.
Yes, those are lathe chucks,
Yeah,
effectively, or part holding chucks
yeah, but then you just the whole round stuff in the
in the mill. Yeah, yeah, that's awesome.
You even got those machines taken care of, putting in new oil for the guideways.
Oh, wow. Was this always out here today?
Yes.
Wow. Look how many pumps there are. 1, 2, 3, 4.
So this one is only a pump for keeping the filtration system of the chip conveyor clean.
Wow.
That's what this pump is for. Now if we go to the other side, we've got
more.
this pump for the flush cooling on the back,
Yeah.
for the flush cooling of the doors, the 1000 PSI.
Yeah, the high pressure.
Yes, this is 20 bars, so it's probably like 300, 400 PSI, something like that. For the lower turret,
Yeah.
because this one I can just switch between 35 and 70
Oh.
bars for the through spindle coolant. And then we've got one pump for cleaning the back of the lower turret.
Oh my god.
So that, and some other flushes down the thing. And the final one, the
knows?
hard question.
I don't know.
Who knows?
I lost track. It
Yeah.
does something.
So we got a tip of the mist collector on here as well.
Yeah, yeah.
We got a mist collector on any machine right now.
Fun thing about titanium chips is they don't cut you. It's kind of weird. Because if that was steel, you'd be,
It always feels fluffy.
you had to actually grab them like that and squeeze.
It's so weird, but you forgot one of the most awesome tools.
Oh,
John.
look at that.
So we just walked past this one. This
Yeah.
is
Another integral 390.
Yes, so it's on a capital C6,
Yeah.
which means we can use it in the multitasking machine and also with the converter on
Adapter.
the
Yeah.
5-axis or the 3-axis
Yeah.
machine. So it's a core mill 390, 2-insert mill with the silent tools.
Yeah, it's awesome. Those are waiting to be run on the Multus?
Yes,
Cool. Wow.
pretty. This is 316 stainless,
Wow.
waiting to be machined there.
Cool. What's the cycle time on the motorcycle peg?
This, I believe, is about 55 minutes.
Wow.
In the way we run it right now.
Yeah.
So now it's just chamfering the front and the little pocket before we get back to the 12 millimeter end mill and rough out the rest of the part. Whereas you can see that since we're taking very light radial cuts, there's still decent speed in there. Because if you take wide radial cuts, you really got to lower the surface speed. So we try and keep the radial cuts light so you can still keep up the momentum. And it helps to not be in the same place rubbing for a long time. Time for the next one. I think they're machining new soft jaws or extra soft jaws to run more parts per cycle.
Ah, got it. Yeah, you're making quite a few. Are we allowed to share what those are?
I think so.
We think so. They're shifter paddles for race cars, which is really cool. They mount on your steering, or behind the steering wheel, right?
Yes.
To do the little tab thing. Really awesome.
So this actually from another Fusion user.
Oh, right?
KMP Motorsports.
That's awesome.
They're based here in the Netherlands, and they're another Fusion user too.
That's so cool.
So
it's crazy.
And they have their own machine shop and machine their own parts.
They've done it. There's a demo of something on them, or a video. Okay, yeah.
Yes.
But like real race car stuff. Like,
yes, real race car.
Yeah.
So they make their own parts, but when they need more stock and they cannot machine them fast enough themselves, we help them out occasionally.
That's really cool.
You haven't seen my workplace, which was actually here.
Was in the CMM room?
In the room where the CMM is right now. But since we bought that, where I've moved
here
to the canteen, I guess.
Yes. Like the workroom. No, but it's cool. You were mentioning everyone comes in at. You guys have a coffee at 7, and then you have a kind of a meeting at 9:30, and then lunch. And
yeah. So what we do, we come in like Jasper, my brother, and I come in early to turn on all the machines, put them all in warm-up programs, stuff like that, and then everyone else comes in around 7 in the morning, and we all drink coffee together. Just they're not necessarily a meeting, because like 9 out of 10 days it doesn't even. Nothing gets spoken about work, but just to be there with everyone, and everyone knows who's there and what's going on today. And then we get to work, and then at 9:30 we have the second coffee break, at 12:30 lunch, and at 3 o'clock our last coffee break of the day.
Cool.
And we all do them together because it kind of gets messy and weird if anyone's just walking around just getting coffee right now and you're not sure why the machine's not running, and you got to communicate all the time about it. So whereas if we just do it all together, we know why machines are not running. You don't have to take over for someone else, stuff like that.
Cool.
And usually we can take those 10 minutes to drink coffee, have a conversation with each other, because it's got to be fun in the end of the day.
Right.
Like,
you got to enjoy it.
You got to enjoy your job. So we kind of want to do it together and have a nice day in the end. So we keep like this.
Yeah, humble brag.
I
like it. I like it.
It's really cool. Like, of course, someone's got to pay for it to get you in there. So it's usually the company who sold you the machine. But it's really cool that if you buy a machine, that you get such a piece in the paper just explaining why you bought a machine.
Yeah, that's awesome.
Yeah.
Cool. Well, Lawrence, thank you very much for the tour. Appreciate it.
Great.
Cool. Hope you folks learned something. Hope you enjoyed. Take care. See you soon.